Hi, my name's Tim Mulrooney. I'm an associate professor in the Department of Environmental, Earth, and Geospatial Sciences at North Carolina Central University, located in Durham, North Carolina. I'm going to be presenting with my undergraduate student, Tysean Wooten, in this paper entitled A Public Participatory Approach Toward the Development of a Comprehensive Geospatial Database in Support of High-Scale Food Security Analysis. This is my recorded presentation. I should hopefully be online while this presentation is going on as well. So we're going to talk about some of the work that we've done, and a lot of our work focuses on the GIS representation analysis with respect to the food environment. And we've got some publications, a couple of publications here. One in applied geography, where we developed a raster-based travel time surface where we compared it against vector-based network calculations. When we studied rural food deserts, we received a grant from the Usda to specifically explore rural food deserts and the GIS representation of food deserts and food swamps. And then we also explored this raster-based metric that we previously looked at to look at relative food availability, and we'll highlight some of the maps that we've created in support of that. So when we talk about food deserts and food swamps and the food environment, to me, a couple of ways that we can quantitatively express geographic quantitative aspects of the food environment is through a food desert. That's been a popular term here in the last 10-12 years in the United States, which is very measurable. So it's got at least 500 people and at least 33% of the census tract's population. So we're looking at both socioeconomic factors as well as geographic factors. And my specialty is GIS analysis, and more particularly data standards, data application of this type of analysis to the food environment. And more particularly recently, we've explored the idea of food swamps, where we look at the relative amounts of energy-dense snacks, foods that inundate healthy options. So typically, if we look at food deserts, it's just the lack of accessibility, and we'll talk about some of these terms here in a second, to healthy food, where food swamps is just the over-inundation of unhealthy food compared to healthy food, no matter how you can measure that. And typically, when we explore food deserts, it's pretty concrete, but food swamps have different ways that we can measure those, and I'll explore these in a second, because what we're really looking at in this paper, in this presentation, is the idea of what are the database needs and the geospatial needs when we do this type of research. So when we talk about pillars of food security, and I try to harken back to our research, is that we look at the digital geospatial representation of the food environment so it can be analyzed, mapped, application of geostatistics. So we have food availability, essentially how close are you to healthy food? And there's a couple of ways to measure it, via density or proximity or variety. And then food access takes into this proximity component, which we talk about with availability, and combines it with some transportation component, which we can get the number of cars or average number of cars per household, or whatever. We can explore how close one is to public transportation or whatnot. And these will be some of the things that we talk about in this paper. Food utilization, meaning, if we do put a grocery market or a farmer's market in a particular location, are people going to shop there, or are they still going to travel to unhealthy food options? And then trying to get to the state of food stability. So our focus has been on the quantitative representation of these facets, essentially. And I work with GIS. I've been involved in GIS for more than 20 years, and it's basically the cumulative information so we can manipulate, analyze, display geographically referenced spatial data. So typically in your vector data model, we've got our points, lines, and polygons. So points could be food sources, addresses. So we've got our sources and our destinations, where people are traveling from, where people are traveling to. We have lines such as roads or streams, and then we've got polygons such as states, zip codes, census divisions, where we can count the number of stores or population or average income or education level or whatever we want that's grouped at that particular level. Because there's different ways that we can measure this food availability. I've talked about the idea of density, which is the concentration of food sources within a particular enumeration unit here. So we can see a census tract or a block group or a zip code here, and you can see in red we've got the unhealthy food sources. In green, we've got the healthy food sources. And we can just look at these measures, these standardized measurements to say, well, in this area, it's got 2 healthy food sources per 10 square miles versus 6 unhealthy food sources per 10 square miles. And look at these for other enumeration units throughout our study area and compare them. We also have proximity. So I have a source destination. We have a destination. So we can look at travel time or travel distance. And in essence, we can look at Euclidean distance, straight line crow fly distance, or we can look at network distance. Okay, and then network travel time. And these are some of the things that we've been doing where instead of exploring straight line distance, which is very easy to do, we can look at more computationally complex and expensive metrics to do this. And so we can explore these metrics as well. And so we can look at a number of different sources, and we can see the average drive time here is 11.1 minutes. The average drive time to unhealthy foods, 8.4 minutes. Because what we try to look at here is how do we compare these? Because an average a drive time of 10 minutes in an urban area is much different than a drive time of 10 minutes in a rural area. And they mean very little without any type of context. And so what the USDA, United States Department of Agriculture, has looked at is the mapping of food desert, which takes in these aforementioned metrics and explore these. And you can see on the left, I've got the food desert, and I'll show in a second here where we get this information from. But we've got food deserts here in Guilford County, North Carolina. And then on the right, I've talked about the whole idea of food utilization. So you can see areas in blue where people spend the most on fruits and vegetables, and the yellow, the least on fruits and vegetables, where we can start to compare these. And we've done this in some of our papers, and we even get a little bit more deeper into the weeds where we explore the margins of error and whatnot with these particular data sets that we work with. Now, these data are extracted from the USDA Food Desert Atlas. So this is this is just a snapshot of the Food Desert Atlas, and you can see up here it explores limited access, low access at 1 mile and 10 miles for urban and rural areas. We have low income and low vehicle access, high group quarters, and we can start to compare some socioeconomic with this distance here. And this is measured at the tract level. So these tracts are relatively coarse. So you can see how large some of these tracts are in rural areas in southeastern North Carolina. In Guilford County, North Carolina, there's about 90 or so of these census tracts, which are sub-county units, which get into a couple hundred of the block groups at which data about transportation and spending is collected, albeit with much higher margins of error. Now, our research, we use the pixel as the granular unit. So we can look at some comparisons from the centroid, but we've grouped these at the pixel level here. So you can see we developed in one of our papers the PRTI, the Pixel-Based Relative Travel Time Index. So for each of these pixels right here, whether it's this pixel here, this pixel here, this pixel here, or this pixel here, the drive time to the nearest healthy food versus the drive time to the nearest unhealthy food. Okay, and we essentially divide those. And so it's just a ratio. It gives the unitless ratio right here. And so this kind of looks at the food balance, which was done by Gallagher in the mid-2000s, which looks at this from the center of a particular enumeration unit. So there's a lot of other factors at play. So we took off on that and explored this at the pixel level, and we were able to kind of group these at the census block group level. And in particular here, we're looking at rural census block groups here for a 4-county region in southeast North Carolina. So you can see here in red, these are areas which essentially are much closer to unhealthy food options compared to healthy food options, while the areas in blue, drive time to healthy versus drive times to healthy versus drive time to unhealthy. And in blue, the drive time to healthy is essentially less when these numbers are less than 1. And what we did in our paper was start to compare these to socioeconomics, income, spending. And you can see this area over here, this area over here in Robeson County is a high minority area. In particular, it's Native American, and you can see the inundation here in this area of just the way that we measure food swamps. This inundation of unhealthy using our measurements for using the drive time to healthy versus unhealthy, and you can see in a lot of these cases the drive time to healthy food is 1.5 to almost 3 times further at the pixel level. So it's computationally expensive, but we only do these computations once. So these are some of the things that we try to do here with this analysis. So with our research questions, what we're looking to do in a limited area, in a time with limited time, personnel, resources, we really wanted to ask when we did this analysis to the GIS user community was what layers are the most important in the study of food security using GIS, what type of attributes are most important. Because when we start to look at SF3, short form 3 data from the census at the county, and in particular the tract and the block grouping or even zip code level, we've got thousands of attributes. So what are going to be some of the most important things, and which facets of data quality are most important in the study as applied to food security analysis? And we'll talk about some of the facets of data quality, because a lot of times, this is my specialty, but a lot of times these things are glossed over. So what we did, and we sent this, and I'll talk about my methods in a second, but when we look at the actual layers, I just put a list of layers, and we developed this with Tysean and a couple of other students who were really interested in this subject. So they did a lot of the legwork on this, but we developed a Likert type survey to distributed to the food desert community that asked about the importance of certain GIS layers. And we were looking at both public and individualized transportation, as well as enumeration units for local scale, high scale analysis, because your national scale food security analysis is going to be focused on entirely different things. We also want to explore attributes. So I talked about these socioeconomics, I talked about spending, income, I alluded to race, ethnicity as well. So I wanted to figure out or gauge what were some of the most important things, because if we were having students develop databases, I really didn't want to have them going through thousands, a couple thousand attributes and finding something that's useless or that's not going to be useful to future research. And then our methods, we sent out to user groups and list servers. We got about 40 responses or so, and we just used a Likert type scale that applied to following scores, since some very quantitative in nature. The not applicable at all earned a score of 1, all the way essential to research earned a score of 5. And you can probably figure out what we started to do here. In addition, with data quality, we had dimensions of data quality that respondents were asked to. And I broke these dimensions of data quality down to logical consistency, positional accuracy, the catalog and metadata, semantic accuracy, temporal accuracy, and attribute accuracy. Making sure, was the NAICS code correct, the square footage or whatnot. And we're working on some research now that we go and field verify a number of the stores in our databases, and we're kind of surprised at the amount of disagreement between some of the data that we're working with and what's actually in the field. So what we did essentially was we just average up the scores, and the highest score was ranked first all the way down to the others. And we had some free forms where people were invited to put in some other things that we don't really think of, because you can see what we focus on, but what other people did. So basically grocery stores were the most important. So for people exploring high scale food security research, grocery stores, roads, farmers markets, urban areas, census blocks, cities and towns, fast food, counties, all the way down to the 21st, 22nd, 23rd that we rated. And then people also added in things like community gardens, greenhouses, arable lands. Some of these would be relatively easy to develop. Some of these would be a little bit more difficult. But you can see, what people rated and felt were the most important. In terms of attributes, the distance to the nearest resource. Now, typically that's going to have to be analyzed or extracted. We're going to have to do some sort of computation to create that, because we talked about the different permutations of distance, drive time, Euclidean, Manhattan distance, or whatnot. But with things like income, race, ethnicity, population density, average household size, those are going to be all important. And then things related to roads like speed limits or number of employees by business were less important. And then the dimensions of data quality, positional accuracy, making sure the actual store was where it was located was most important. Attribute accuracy was second most. And we just basically averaged the scores that everyone gave us and then ranked them from 1 through 6. And then I wanted to focus a couple of things on the standards-based approach to metadata. When I went back here, the semantic accuracy I thought was important because I've done some previous work with SDSFIE, spatial data structures for facilities, infrastructures, environment. So where we try to maximize interoperability using naming convention attributes, domain values, and that kind of ties in with attribute accuracy and especially semantic accuracy, making sure everything is consistent. The FGDC, which has defined data standards for landmarks addressing thoroughfares, parcels, so they can be geo-coded, and the CSDGM, ISO, North Carolina State and Local Government Profile. And this is a previous research grant that we had where we developed metadata standards based on the ISO 19115 standard for cataloging descriptive, administrative, and structural information about geospatial data. And I wanted to focus on that a little bit, even though it was the least important, but I wanted to focus on this. But we used a state and local government profile as a guideline to the development of data, because we did find a number of temporal accuracy issues when we were doing some field verification, and I wanted to kind of talk about some of these things for a minute, especially when we talk about high-scale food security research that we should be cognizant of. But we're exploring process description, making sure how the data were developed, the topic category. I think there was about 21 ISO topic categories, making sure they're in the appropriate place, and the feature catalog, which entails the entity and attribute descriptions and citations referencing ISO 19110. Other elements, data quality and elements that aren't included in our North Carolina, our homemade state and local government profile, but things like attribute accuracy reports. There's about 410 elements in metadata, but our quantitative attribute accuracy assessments, and you can see some of these entries here that are mainly focused on how do we explain accuracy, because a lot of times, and I'm guilty of it as well, that we take for face value some of the data that we receive, and the GIS community hasn't thought critically and holistically about the actual data that's gone into it. So I thought it was interesting. There's been some research on exploring some of the commercially available business data out there, some of the different data sets that we take at face value, but I think it would be interesting if we did some field verification, and the GIS community did some field verification. They should think critically about some of these elements, and these were just some suggestions for moving forward. In conclusion, I think that the needs, and I think Tysean can agree because he's done a lot of the actual work in mapping for me when we have projects across campus where he's working with students. But the needs for local level food security different than regional and national scale analysis. So people like looking at spending at the block group level or the tract or the zip code level, and we bring together all of these different databases. We thought it was kind of interesting that geospatial data related to individualized vehicular transportation rated higher, much higher than public transportation and pedestrian transportation. So roads were ranked very high, while bus stops and pedestrian transportation, because we're not only focused on rural but urban. A lot of our research in the past has been in rural areas where pedestrian transportation isn't a possibility, and even public transportation isn't. But we thought it was interesting where, food security is dependent upon individualized vehicular transportation, when we teach on a campus where a lot of students don't have access to a car, but a supermarket is walkable, and we have bus routes on campus. Sub-county census units such as census tracts and block groups were ranked higher than counties. So I thought it was interesting that people like looking at sub-county data, but even though it was less reliable, because it's got less of a sample size, so a higher margin of errors. So people were willing to trade off that less reliable data for they were able to accept that less reliable data than the more reliable lower scale data. So I just thought I thought that was interesting, and I hope people can think critically about some of those. And lastly, information related to distance and socio-demographic indicators such as income rate, ethnicity, household size ranked highest. And it just ties in directly with food desert research, specifically the definition of food deserts, which utilize both distant and poverty components, which are explicit in its definition. So my name's Tim Mulrooney. I'm an associate professor and graduate coordinator in the Department of Environmental Earth Geospatial Sciences in Durham, North Carolina Central University. And this is Tysean Wooten, who's done a lot of work in our food desert research, and who's done a great job with a lot of this work. This project's been supported by both the USDA, and then we currently have a grant with a partner and through NSF, which is also we're also doing this work. So thank you very much, and I hope you liked it.